Hello everyone, welcome to my channel Wish Infinite. In this video of Playwright with TypeScript series, I will talk about how to encrypt and decrypt sensitive data in Playwright using CryptoJS. And before proceeding further, I would like to inform you that you can now support my YouTube channel by clicking onto this join button and select the desired option to become a member. You can unlock exclusive perks while helping the channel grow. Your support means a lot. Also, I have created YouTube Shorts playlist for Playwright. You can watch this playlist to refresh your Playwright concepts. I will provide link of the playlist into description, or you can go to my channel Wish Infinite and under the playlists tab, you can access this Learn Playwright in 60 seconds Shorts playlist. You can click onto this community tab where you will be able to see this Playwright quiz. You can search in the browser with the keyword Playwright with TypeScript to see all the questions. You can answer these questions, which will help you to prepare for interview also. I have also uploaded the latest code of this series onto GitHub. You can visit my GitHub profile where you would be able to see this Playwright tutorials TypeScript JavaScript repository. I will provide link of my GitHub profile and of this repository into description. Now coming back to our current topic. So credential encryption is essential in automation testing to ensure the security and confidentiality of sensitive data. Automation tests often involve sensitive information such as login credentials, API keys, or tokens. Encrypting these ensures they are not exposed to unauthorized access, especially in shared environments like CI/CD pipelines. That's why we should never hardcode raw credentials or encryption keys in our test scripts. Hardcoding credentials is not secure and as well as it is not recommended. On Git also, we should not push our credentials. We can use library like CryptoJS to handle encryption and decryption of credentials. Now let's proceed further with prerequisite installation. So first important node package which we need to install is crypto-js. And to install this package, we need to give the command which is npm install crypto-js. We can use only I in place of install also. Now let's proceed further with the installation of this crypto-js node package. So let me open VS Code. Here in my project, inside the tests folder, I have already created one test script file with the name Encryption Decryption with Playwright. And inside this test script file, I have already imported test from Playwright test module where I have created one test with the title Encrypt Decrypt Sensitive Data in Playwright and passed the second argument as the anonymous function where I have passed the page fixture, and inside this anonymous function, I have written the code to go to this particular URL which is sourcedemo.com where I am entering username and password and then clicking onto this login button. So this script will open this sourcedemo.com link where it will enter username, password, and then it will click onto login button which will take us to the login page. So now let's install this crypto-js node package. So for that, we need to give the command npm install, or I you can give as the short form. Then we need to give crypto-js. And as soon as you will hit enter, this particular node package will get installed. Inside the package.json also, you would be able to see this crypto-js with its version. So now let me hit enter. Now the package is installed, and here inside the package.json, you would be able to see this crypto-js under the dependencies with the current version. This version can change as per the release. Currently for me, the latest version is 4.2.0. Now let's proceed further. There is one more prerequisite. For now, I am not installing it. This one is optional, but I will tell you why we need this particular prerequisite. Now, as we have installed the CryptoJS package, so now let's move to the next step, which is to encrypt the credentials. And once our credentials are encrypted, we would also be decrypting those credentials and then we will use it into our test scripts. So let me write that down here. So first encryption we would be doing, then decryption, and then we would be using that decrypted credentials into our script. So to encrypt the script, we would be using this CryptoJS package. So here into our TypeScript file, we need to first import the crypto-js package. So for that, you need to provide import CryptoJS from crypto-js. And now we are going to use this imported CryptoJS to perform encryption and decryption. So let's first encrypt our credentials. So here into our TypeScript file, we have this username and password which we would be encrypting and then decrypting. Apart from the username and password, there can be API keys or tokens or any other sensitive data which can be there into your project that you can encrypt. So let's first encrypt this username, and for that we need to use this CryptoJS. So before using these credentials into your test script, you need to encrypt them. Anywhere into the script you can do that. It should be before using. So here CryptoJS dot we need to provide AES. So AES module of CryptoJS is used for advanced encryption standard, encryption and decryption. AES is a widely used secure encryption algorithm. And after AES, we need to provide dot, and here we need to use encrypt method. Here we are not able to see auto population or any details related to this method for now. I will tell you how we can see those details also here into our VS Code. And with this encrypt function, we need to pass the arguments. And the first argument would be the string which we want to encrypt. So in this case, here we want to encrypt username. So provide username as the first argument to this encrypt function. Here you can use single quotes, double quotes, or the backticks, whatever you prefer. And then the second argument would be the secret key which we need to pass with this encrypt method. And this secret key which we will pass to encrypt our credential should be kept at the secure place, because we are going to use the same secret key to decrypt our credentials. If someone is not having this secure key, they would not be able to decrypt the credential. So that's why passing this secret key is very important, and it should not be public into your script. So here for now, I will directly pass that secret key into the script, but I will tell you how you can pass this secret key while doing the execution. So here for now, I am passing the secret key as wish infinite. All small cap I have passed. You can pass any secret key. It's your choice, but you need to use the same secret key while decrypting your data or credentials, right? And this will give us the encrypted data. And as I told you, we are not getting any suggestions or any details related to this function. Why? Because here if you will see onto this crypto-js also, if you will mouse over, they are saying that could not find the declaration file for module crypto-js. This is just the warning which we are getting. And to avoid this, we need to provide this npm I -save -dev and then @types /crypto-js. So that's the same prerequisite which we have provided here. And once we will install this prerequisite, this particular warning will go away, and we would also be able to see the suggestion and details related to this package. So let's install this prerequisite. So open the terminal. Here we need to provide the command npm I, or install you can provide -save -dev @types /crypto-js. And why we are installing this particular prerequisite? Because TypeScript requires type definitions for all the modules we import. So here we have imported this crypto-js, but this crypto-js library does not come with its own type definitions. So TypeScript treats it as an untyped module. leading to the warning. So now let's install this, and after installing the type definitions through this particular command, TypeScript will understand the types for crypto-js and the warning will disappear. So see, we are not able to see that warning here now. So here we have installed type definitions for crypto-js from definitely typed, a community driven repository of type definitions. So now as the warning is gone, and here if you will again use this crypto-js dot, see, we are able to get this auto population through the VS Code because we installed type definition after AES dot, and see, we are able to get this encrypt and decrypt auto suggestion. And here if you will mouse over onto the method, you would be able to see the detail related to that particular method. So that's why I would recommend you to install both the prerequisites for your project. Let me remove this line. Okay. And this encrypt method returns us the object of type cipher params, which will contain the encrypted data and metadata. And we need to convert the response from this encrypt method into the string format. And for that, we need to use this toString method, which will give us the encrypted value into the string format. Let me save this value into one variable. So const encrypted username, I will give the variable name. And let me console log this encrypted username. Let me comment out this part for now. I will just encrypt the username and then I will console log the same. Let me type this encrypted username here. Just for console logging purpose, I am providing it. Now let's execute the script. And here we have directly hard coded this secure key, but it is not recommended to hard code this secret key. We will see that how we can pass it during execution. For now, I will start the execution with this hard coded secure key value. You can also call this secure key salt. Here you can use npx playwright test or this playwright extension to start the execution. See, the execution got completed and we are able to see this encrypted username. So let's copy this encrypted username and we will save it into one variable. So const any name you can give. Here I am giving this encrypted username or uname equals to this value which got generated. So as the string, you can save it. So this is the one-time activity where we have encrypted our data and we can use this encrypted data here. In this case, it is username further into our script after decrypting it. So now let me comment out this encryption part and again let's encrypt the password. And for that, again, we need to use this CryptoJS.AES. See, we are getting this auto suggestions from the IDE dot encrypt. And here, first argument, we need to pass as the string which we want to encrypt. So here it would be this secret sauce, which is our password. So here as the string, we need to provide our password, comma, and the second argument would be the secret key or the salt, whatever you want to call. So here I will provide the same secret key dot to string to convert it into the string format. Now let's console log it. So console dot log and then this encrypted password. Here it should be console. And here let's provide one string to identify this one into the logs. So encrypted password. And now start the execution so that we would be able to see the encrypted password into the console log. So here I've started the execution and we are able to see the encrypted password this time. This encrypted username part I have already commented out. So now let's save this particular password also into one variable. So const encrypted password pwd equals to, as the string, we need to save this particular value. So this is our encrypted username and this is our encrypted password. And this data we would be saving and pushing to our repositories. every time this data is going to get used, we will decrypt this particular data, and then we will use this data, in our case username and password, into our script. It can be any data which you want to encrypt. So now let me comment out this line also. We need not to again encrypt it. So here both the parts I have commented. Here I have saved this encrypted username into one variable, then printed it. And here I have directly printed the encrypted password value inside the console log. So don't get confused. We have followed the same process to encrypt our username and password. Now let's decrypt this encrypted username and password. And to decrypt our data, again we need to use this CryptoJS .aes we are going to use this decrypt method. And here we need to pass two arguments with this decrypt method also. So the first argument would be the encrypted data. So here we have this encrypted username. So first let's decrypt that. And then we need to pass the second argument to this decrypt method. And this second argument would be the same secret key or the salt which we have passed while doing the encryption. So this secret key or the salt should be exactly similar which we passed during the encryption. Otherwise, you will not get the correct decrypted data. And this is called symmetric encryption. The same key is used for both encryption and decryption. So that's why it is important to remember this particular secret key which we are using while encrypting our data. And it should be kept at the secure place, or it should be passed while starting the execution rather than saving it or hard coding it directly into your script. For now, I am directly hard coding it, but I will tell you the way going forward that how you can pass it while starting the execution. So here the second argument I am providing as the wish infinite, right? As the string you need to pass it. And this decrypt method is going to return us this cryptojs.lib.word array, which is an object containing raw bytes of the decrypted data. And we need to convert this word array object into the string format. And for that, again, we need to use this .toString method. And here inside this .toString, we need to pass this CryptoJS.enc.utf8. So this CryptoJS.enc.utf8 is used while decryption to convert the decrypted data which is in raw byte array format into human readable string. So every time while decryption, first you need to decrypt your encrypted data, and then you need to use this .toString, and inside this .toString we need to pass this CryptoJS which we imported .enc.utf8 to get the data into human readable string. Now let's save this value inside one variable const. Then you need to provide the variable name, and this is decrypted username. So I will give decrypted uname here. Any variable name you can provide. So inside this variable we should get the decrypted username into the string format. So now let's first console log this username to see that we are getting our correct username or not. So we should receive this username, right? Because we have encrypted it and now we are decrypting it. So this is the encrypted username and now we are decrypting it. So we should be able to get the original data. So console.log, and here let's provide this variable. And now let's execute the script so that we should be able to see this original username after the decryption. See, this console log we are able to get because we have decrypted this value using this decrypt method. And rather than console logging it, we can directly use it also into our script. Let me uncomment this part now. And similarly, we can decrypt our password also. And for that also, we need to use the same way const decrypted password or pwd any name equals to CryptoJS.aes And as we want to decrypt this encrypted password, so again use this decrypt method. First parameter would be this encrypted password, and then the second argument would be the salt or the secret key. So the same value I'm hard coding here, dot toString, and here inside the toString we need to pass this CryptoJS.enc.utf8. And now we can use this decrypted password into our script. So here we need to pass the decrypted password, right, for this password field. So let me provide this variable name here. Let's console log this password also, just to see that what we are getting as the decrypted password. Console logging this decrypted password is not important, right? Just to show you that what we are getting, I'm console logging, but we had to console log this encrypted password to see it, and then we can copy paste it into our script to use it. Although this encryption would be the one-time activity, but every time once you have this encrypted data, you will have to decrypt it before using it, right? So here we are decrypting username and password. Every time this decryption should be happening before using it. Otherwise, if you will directly use this encrypted username or the encrypted password, your script will get failed, because these are just the string which will get directly used into these fields, right? And this value is not correct, because we need this username, this password, right? So that's why it is necessary to decrypt the encrypted data. Now let's start the execution, and this time this value should get filled, and also we would be able to see the console log for this password. See, this secret sauce was our original password, right? So we used this encrypted password, we decrypted it, and then we used it inside our script. And if you will open the browser, see, we are able to successfully log in into our sauce demo application, because we entered the decrypted username, decrypted password, and then we clicked onto the login button. Let me remove this console log also. And that's it, right? We are able to encrypt our data, and then we decrypted it, and then we used it inside our script. And as I told, we should never provide the secret key or salt directly into our script, and we should not save the same into our script, right? So how we can avoid it, right? While encryption also we provided it here, although we are not going to save this encrypted code, right? We can remove it. For now, I've just commented out for your reference. This was only one-time activity. So we have encrypted our data and we have console logged just to use it further, right? But while decrypting, every time we will have to provide the same secret key which we have used while encryption. And here for now we have hard coded it, but that is not the recommended way, and we should never do that. So to avoid it, what we are going to do, we are going to use the environment variable. So on place of the secret key, we need to provide this process dot env dot the environment variable name, which we would be passing while starting the execution. You can give any name here. You will have to use the same name while providing it during the execution. So here, let's give this environment variable name as the secret key. Secret hyphen key I am providing. Any name you can provide, the same name we will have to use while passing the value. So to this particular environment variable, we would be passing the value, and with the help of this process.env.secret key, we would be able to read the value which we pass through the command line. Here we are getting this warning because this process.env.secret key is going to return us either the string or the undefined, right? Because while starting the execution, there may be the case that user is not providing the value itself. In that case, it can receive the undefined. And to avoid this particular error, let's save this process.env.secret key into one variable. So const secret key, any variable name you can provide, equals to this process.env.secret key. And as we are using TypeScript, either we can pass this any here, and then if you will use this variable name, you will not get the error, because if you will not use this any, again you will get the same error. So either use this any to tell the TypeScript that it can be of any type, or rather than providing this any, what we can do here, we can mention that if this value is not undefined, right? If user is passing this value while starting the execution, so in that case, we want to save this value. So here I'm using the ternary operator. So if we are having this value, okay, so this case would be true. So if we are getting valid value for this secret key, so we want to save the same value inside the variable. Or if we are getting undefined, so we are going to get this blank value. If you do like this, then also you will not be seeing any error, because if you are getting the value with the secret key, it will save it inside the variable. Or if you are getting undefined, then we are saving the blank string. And if it is undefined, automatically your decryption would not be successful, right? So if this value is not defined, you are not passing it while starting the execution, you would be saving this blank string here inside the secret key. And then if you are using this blank secret key, your decryption would not be successful. So it would be mandatory for you to every time pass this secret key while starting the execution. If you are starting the execution manually, you will have to provide it while giving this npx playwright test. If you are using CI/CD through Jenkins or Azure DevOps, there is provision to pass the parameters to the script. We have already seen the continuous integration using the Jenkins or the Azure DevOps into my previous videos. If you have not watched those videos, I would recommend you to watch these continuous integration related videos. I will provide link of these videos into the description, or you can click onto this I button at top right corner to access those videos. And similarly, for this password decryption also, we can use the same secret key. And now, what would be the next step? We need to pass this particular value, because for now, this value is undefined, right? And if we are not defining the value, we are passing the blank value, right? Using this ternary operator. So if it is true, it should take this value. And if this expression is giving us false, then it should take this value. Simple ternary operator. This is JavaScript concept. So now let's start the execution so that you will have an idea that how to pass this secret key. And to start the execution and to pass this secret key, we can use any of the terminal. It can be cmd batch terminal, or the PowerShell terminal, or the bash terminal. Although passing the value to the environment variable would be different for each of the terminal. So let's first start with this batch or the cmd terminal. So mostly you would be seeing this batch cmd terminal and the PowerShell terminal into the Windows machine, and this bash terminal into the macOS or Linux machine. So now let's see how you can pass the environment variable value and how you can start the execution into the cmd terminal. And for that, this is the syntax. You need to provide this set and then the environment variable name. So in our case, the environment variable name would be secret underscore key equals to, and then we need to set the value. So whatever the value we need to pass, in our case, our secret key was wish infinite, which we have used while encryption. So the same secret key we would be passing, and after hitting enter to set the value, we need to give the command which is npx playwright test. So let's open the batch terminal. Here, go to the terminal, click onto this arrow, and from here you can select this command prompt to open the batch cmd terminal. Similarly, you can select the PowerShell or the bash terminal. Although I'm using the Windows, but I have installed this git bash, so that's why I would be able to use this bash terminal also into Windows machine. So let's open the cmd terminal first, cmd or batch terminal, right? Both are same. And here, let's first set the value of this environment variable, which is secret underscore key, right? Which we passed with this process.env. So set secret underscore key, all capital, equals to the value of our secret key. So in our case, it is wish infinite, which we have used while encryption. All small I have passed. If you have used any number or any capital or small letters, the same value you need to pass. You can keep any complex secure key with you, right? So that no one would be able to guess it and they will not be able to decrypt it. Now, set environment variable equals to its value. hit enter, and now we can use this npx playwright test. And now let's console log this decrypted username and password just to see it that correct values are appearing once we are doing decryption, where we are passing the secret key through the environment variable. So console.log, and here let's pass the username and password inside the same console log. So username plus I will concatenate it with the hyphen, so space hyphen space again plus to concatenate this string with the password. And now let's start the execution. Let me close this browser, and now we would be starting it through the terminal. Why? Because if I will start directly using the Playwright extension, in that case it will just use the npx playwright test command at the backend, but it will not be setting the value of this secret key environment variable, and we would be receiving blank secret key, right? Because it would be undefined and our decryption would not be correct. So that's why we are using the terminal. So here we have already set this secret key to the Infinite through the batch command. Right now we are starting the execution using the npx playwright test. Hit enter, and as soon as you hit enter, you should be able to see the decrypted username and password as the console log, and here also it would be successful, right? Our execution got successfully completed, one passed, and see we are able to see this username, which is standard user, right, hyphen the password, our correct password, which we got through the decryption when we decrypted these encrypted data. So here we used the cmd terminal, where we first set the value of our secret key, then we started the execution. Now let's use this PowerShell terminal, and inside the PowerShell terminal the syntax is $env colon and then the variable name equals to, and then as the string we need to pass the value. So let's open the PowerShell terminal, click onto this down arrow, select PowerShell, and here let's use this syntax. And if you are using PowerShell, you can pass this command in the single line itself. So previously with the batch command, we have set the value of the variable first, then we have started the execution into the next command. But here into the PowerShell, you can separate the two commands with the semicolon. So let's use this $env colon and then our environment variable name equals to, and then within the single quotes we need to pass the value. So wish infinite, closing single quote, and then semicolon, and then we need to pass this npx playwright test. Within the single line we are able to do so, right? We need not to pass it one by one. And now hit enter, and again we should be able to see one passed with the correct username and password. See, we were able to log in successfully, and here we are getting the username and password once we started the execution through the PowerShell command. So it's totally up to you which terminal you want to use, right? You would not be using all the terminals, but you should be aware, right? Otherwise you will get confused, right? Because in some project, let's say if you are just using the PowerShell terminal, and if you will not be aware about the syntax, so you will not be able to set the environment variable value, right? So that's why I'm covering all these terminals, that how to pass the value for our secret key, which is the environment variable. And now let's use the bash terminal. And for the bash terminal, the syntax is the simplest one. Here you need to pass the variable name equals to the value of that environment variable. After space, we need to provide this npx playwright test, right? So let's use the bash terminal. Click onto this down arrow here, as I have installed the git bash, so I will open the same. If you are using macOS or Linux, you would be getting your bash terminal, and here let's provide the value of this environment variable, which is secret underscore key. This is the environment variable name equals to its value, which is wish infinite space npx playwright test. Hit enter, and this time again the execution should be successful, right? The execution got successful, and we are able to see the correct username and password. And while starting execution, if someone is passing this secret key value wrong, they would not be able to decrypt this username and password. And here your script will not be successful without the correct username and password. So keep this salt or the secret key at safe place where you and your team members only have access who are going to start the execution. And one more bonus thing for you. So as I told that this encryption would be one time activity, right? So either you can use this script to encrypt your data and then you would be using it for your script. Either you would be saving it inside the variable or you would be using external files like .env or JSON file to save this encrypted value, right? So one time only you will have to generate it, log it, and then save it for your future use. So rather than using this particular code, you can use one extension. So let me show that extension to you. Click onto this extensions and search for Encryption VSCode. And you would be able to see this one extension by James Bacchini. You can install this extension. So click onto this install. See, if you will read the description here, they have written that AES encryption and decryption for the current file content in the Visual Studio Code. And here is the process. So you will have to press the Control Shift P and then you can select encrypt or decrypt. You can pass the passphrase, which is secret key, and it will encrypt or decrypt the current document. So mainly we want to encrypt it because decrypt every time we will have to do it, right? We don't want to do it manually, but encryption would be the manual process, right? Because you will have to encrypt the data and then you will have to save it into your external file or into your TypeScript file, right? So that process we want to make simple. It's totally up to you. It is not necessary to use this extension, right? We can create one utility where we can pass just the username to the function and it should generate this console log. So whatever the way which is preferred by you, that you can use, but just I want to show you that we can use this extension also for the encryption. So let's create one blank file, right? And here let's pass our username, which is standard_user. So this is the username which we want to encrypt, right? Here I have created just the blank file without any extension, right? Any file you can create if you have some temporary file, or you can create one TypeScript, any file with any extension you can create here where you need to provide this value, right? You can also use the text file. Now press Control Shift P. If you are using Mac, then you will have to press Command Shift P, which will open the command palette. And here we need to click onto the encrypt. If you are not able to see it at the top, just type it. It will come at the top. Select it, and here we need to pass the passphrase or the secret key or the salt, whatever you want to call it. And here we would be passing it as the wish infinite. So any secret key which you want to keep, that you can pass here. And now hit enter. So as soon as you will hit enter, it will encrypt the data. Every time you will get some new encrypted data, and this encrypted data you can use for your test scripts. Let me use this encrypted username here into our test script file. So let me replace this encrypted name with this one, which got generated through the Encryption VSCode extension. And the same thing we can do for the password or for any other data. So whatever the value which would be there inside the file where we are pressing this Control Shift P will get encrypted. So just keep one value inside the file which you are going to encrypt. Otherwise, it will combine all the data and then it will encrypt it. So the same process you can follow for the password, where you can pass this secret sauce inside this file, press the Control Shift P, pass the secret key, hit enter, and it will generate the encrypted data. For now, I have replaced our old encrypted username with this new encrypted username. I've used the same wish infinite key to encrypt this username. You can try it for the password also. And now I can start the execution, right? I can use the same process. You can use any of the terminal. pass the secret key as the environment variable, start the execution, and then it will decrypt the encrypted data, and it will use that decrypted data into your test script for execution. See, our execution got completed, and here we are able to see the username and password also. So it's totally up to you through which way you want to generate your encrypted data, either by using this code or by using this extension. This is completely optional to use this extension. Here, one more thing, if you want to re-verify, you can decrypt it through this extension also. So press Ctrl+Shift+P, open command palette, search for this decrypt, click on it. Here you'll have to pass the same secret key which you have used for this particular encryption. So I will pass the wish infinite, hit enter. See, our data got decrypted and we are able to get the decrypted human readable string username. So like this, you can encrypt any data and can use it for your execution. Just for the check, I have decrypted it here, but to decrypt data, every time you'll have to decrypt it inside your script only. For this encryption and decryption, rather than using it directly inside your test script file, we can create one utility where we can create function for the encryption and decryption, and then we can use those functions rather than every time writing this complex code here into our test script file. So now let's see how we can create utility function to encrypt and decrypt our data. I have marked this particular step as optional, but it's better to create utility, right? Rather than every time writing this code, it's better to reuse the utility function. So to create the utility, let's go to the VS Code. Here, let's create one utility folder where we would be creating our utility to encrypt and decrypt data. So right click onto the new folder. Here you can give any name. For now, I'm giving the folder name as util. Hit enter. You can create utility at any place, either within this folder or directly inside the project also. You can create the utility. It's totally up to you. Then right click onto the folder, click onto the new file, and here we can give any name for our utility file. Here, as we are going to create utility related to the encryption and decryption, I will give the name as encrypt decrypt util.ts. So encrypt decrypt util.ts. Hit enter. And here we need to create two functions, one for encryption and one for decryption. So let's create two functions. So function and then the function name. So for the encryption, let's give the function name as encrypt data, and here we would be writing the code to encrypt the data. And one more function we need to create for the decryption. For that, I will give the name as decrypt data, and here we would be putting the code related to the decryption. You can choose any name for your functions. Now we need to place the code here inside these functions to encrypt and decrypt data. And which code would be appearing here? The same code which we have just written here inside our test script file. So let's start with the encryption portion. So first thing, we will require CryptoJS inside our util file. So let's import CryptoJS here. So import CryptoJS from crypto-js. And here to encrypt the data, we need to use this crypto.aes.encrypt, where we would be passing the data which we want to encrypt and then the passkey or the secret key. So here cryptojs.aes.encrypt, and here first value would be the data, right, which we would be taking as the parameter, right? So here you can mention data. So whenever we will call this function, we would be passing data with that function which we want to encrypt, and then the second argument for this encrypt would be the passkey. So as we discussed, we need to pass this secret key by starting the execution, as we just saw. So for that, we would be using environment variable. So here into our test script file also, we have used this process.env and then our environment variable to set the value of this secret key. So we can use the same line here into our test script file. Let me write that down. So here const secret key equals to, and then process.env dot environment variable name. Secret underscore key is the name which I will give. You can give any name here. And as we discussed earlier also that this environment variable may return us either the string or undefined. So for that we will use the ternary operator. So if we are getting any valid value here, so we want to save this particular value. So after question mark, the true part which we want to do, otherwise colon, and then if we are not getting valid value here, which means that if we are getting undefined here, then we want to save the blank secret key. And now we can directly pass this secret key here as the second argument to the encrypt method. And now we need to convert this particular value as the string. So after dot, we need to give two string here. So by this particular code, we would be getting the encrypted value. Here we can directly return this particular value to get the encrypted value once we call this particular function. And here, as we are using TypeScript, so we can define the type of this particular parameter, which would be string. And as we would be using this encrypt data function into our TypeScript file, for that we will have to import this particular function. And to import it, first we will have to export this particular function. So here we need to provide export before the function. So export function and then the function name. And now let's put the code for the decryption here. So for the decryption also, as we have already done it using the decrypt method, so let's provide this particular code there into our utility. So again, CryptoJS.AES.decrypt method we need to use, and here we need to pass the encrypted data. So let's keep the parameter name as data only, colon, and it will be string. So here we are providing type of this particular parameter. And inside this decrypt method, first we need to provide this encrypted data. If you want, you can give the name as encrypted data or any name you can give, right? For now, I will give the name as enc data, comma, and here we need to pass the secret key. So this is our secret key which we would be passing while starting the execution. And now, as we discussed, we need to convert this decrypted data into human readable string format. So to string, and here we need to pass this CryptoJS.enc.utf8. And now we can return this particular value, which will give us the decrypted value of the encrypted data. And this function also we want to use into external files. And for that, first we will have to export this function from here. And then we would be importing these functions into different files. So now our utility is ready. Now we can directly use this method rather than writing this code every time whenever we want to encrypt or decrypt data. Although we have already done the encryption and we have got the encrypted data, but just to show you, let me console log again the encrypted data by using the utility. So here, let me add this code here so that side by side you would be able to see. So const encrypted username equals to, and now rather than writing this particular code, we would be just calling this particular function. And to call this function, first we need to import. So import within the curly braces, we need to mention the function name, which is encrypt data from, and here we need to mention the path of our encrypt-decrypt.util TypeScript file. So double dot forward slash, which will take us to the parent folder, and here we have the util folder, and inside it we have this encrypt-decrypt-util ts file. And similarly, let's import the decrypt function also. So within this curly braces only, you can provide this decrypt data. We are using curly braces because these functions are exported without using default keyword. And now let's use this encrypt data, and here we can simply pass the data which we want to encrypt. So here we want to encrypt this username, so that we can pass, and that's it. Your data will get encrypted and it will get saved into this particular variable. And now you can console log this particular value and can keep it for your future use. So let's console log this particular variable. And similarly, you can encrypt the password also or any other data. Let me comment out this particular portion so that you would be able to see that our data is getting encrypted properly using this particular utility. Now let's execute the script. So let me open the terminal, because while starting the execution, I would be passing the secret key. Let's use the bash terminal. Let me open one new bash terminal. Let me close all these old terminals. And here, as we saw for the bash terminal, we need to provide the environment variable name. So secret underscore key, all capital, equals to wish infinite. This is my secret key. It can be different for you, whatever the key which you want to set. And then npx playwright test. Hit enter. And see, we are able to get the encrypted data. And our execution also got passed. And like this, you can encrypt multiple set of data and can console log them, and then can save it for your further use. Like here, we have saved it inside the variable. You can also save this encrypted data into JSON file or into environment file, wherever you want to keep your encrypted data. So now let me remove all these comments and let's comment out this part. For now, we need not to encrypt our data. We already have encrypted username and password. And one more thing, every time whenever you will encrypt your data, you will get different value for the same secret key also. But once you will decrypt it with the same secret key, you are going to get exactly same decrypted data every time. So now let's use this decrypt function to see that our decrypt utility is working fine or not. Let me paste this code here related to the encryption. And now let's decrypt our username and password. So let me comment out these 3 lines which we were using to decrypt data directly into our TypeScript file. But now we have utility, so we need not to provide this code here. We will use our utility. So secret key we have already provided here, right, into our utility. So every time we will not have to put it into our TypeScript file. And here let's use this decrypt function which we have already imported. So let's create one variable, same decrypt username equals to, and here we will use this decrypt data function which we have created, where we need to pass this encrypted username, and that's it. We will be able to get the decrypted data through this particular function. And similarly, we can decrypt our password also. So parallelly, we are refactoring our code also. Previously, we had to write all this code, but now we are just simply calling the function which is returning us the encrypted and decrypted data. So to create decrypted password, let's create one variable const. Decrypt pwd is the variable name which I am giving, equals to decrypt data method, and here we can pass this encrypted password which will return us the decrypted password. And these variables where we are receiving decrypted username and password anywhere into your TypeScript. So here we are just console logging, and then we are using it to fill the username and the password, and then we are clicking onto this login button. So here, see, after refactoring, we don't need this particular code. And for the encryption also, only you'll have to just call this method if you want to encrypt any new data. And this encryption is one-time activity because you would be using that encrypted data for your future use. But the decrypt code is going to be there every time, because every time we need to decrypt this encrypted data. So that's what was our goal, right? We are not using our actual confidential data into our TypeScript file. We are encrypting it, right? Here we encrypted username and password, and then we are keeping this encrypted data into our script. And every time we are decrypting this particular encrypted data, and then we are passing it to our TypeScript wherever we want to use it. So only the person or the team members who knows about the secret key which is used to encrypt the data can decrypt the data. For now, I am keeping this particular commented portion for your reference rather than removing it. And we can remove this import of CryptoJS also, because we are not using this CryptoJS anywhere into our test script now, because we are using it inside our utility file. For now, let me comment it out for your reference. And here I have created functions, but you can also create one class, and there you can create such methods that you can use inside your test script files. So it's totally up to you. For now, I wanted to keep it simple just by creating the functions. But as an assignment, you can try it where you can create one class and then you would be creating methods to encrypt and decrypt data that you can use inside your test script files. For the reference, you can see the code which we have used while creating the page object model, where we have created the class and then we have created methods where we can put our desired code. Just for the reference, you can check this page object model video also if you want to use the classes and methods to create the utility. So that's your assignment. You can try it, and if you face any issue, you can let me know into the comment section below. And now this step is also done, where we have created utility functions to encrypt and decrypt data, and we have used that utility. So now here our main work related to encryption and decryption is done now. And that is the main process which you will have to follow to encrypt and decrypt sensitive data. And now I want to cover some additional steps where we would be keeping this encrypted data into external files. It can be .environment file or the JSON file or any other external file. And then we would be reading encrypted data from these files. We would be decrypting that data, and then we would be using that particular data into our script. So till now, we were keeping encrypted data directly into our test script file. But usually into real-time projects, you would be keeping your data into separate files. If you are maintaining multiple environments, you would be using .env files. About handling multiple environments and using .env file, I have already discussed into one of my previous video, which is this execute test in multiple environments with Playwright. If you have not watched this particular video, I will provide link of this video into the description, or you can click onto this I button at top right corner to access this particular video. For now, first, I will quickly show you that how you can keep this encrypted data into .env file. To get in-depth knowledge, you can follow that video. So let's create one .env file anywhere into your project folder. You can create such file. For now, I will use this test data folder, which we are already having, which we have used previously for this particular playlist. You can create any new folder also. For now, I'm using this folder. Click onto this new file, and then .env is the file name which we need to provide. And here we need to simply provide key and value pair to save data inside this .env file. So the key would be the name which we would be using while retrieving data. So here let's keep this same name, encrypted username or uname equals to, and here we can provide the encrypted data. So this is our encrypted username. I will copy the same name here. After encryption, rather than keeping these values here, you can simply keep it inside the .env file if you want to use this .env file to save the data. Hit enter, and here we can keep this encrypted password. So encrypted password equals to, and then its value. And similarly, you can keep multiple sets of data here with this key value pair format. And now we have saved our encrypted data. Let me create one more test block just to keep things clear. Otherwise, it would be hodgepodge inside the same test block only. Here, let's give the name encrypt decrypt 2. And the second argument would be the anonymous function. So async parenthesis arrow symbol and then the curly braces. And here we would be decrypting our data, and then we would be using it into our test script to pass the username, password, and then we would be clicking onto login button. So let me copy the same code. Here we need page fixture. So within curly braces inside this anonymous function, we need to provide page. So this error is gone. Now we need to provide decrypted username and password. And for that, again, we can use our utility, right? We need not to write this code again to decrypt data because we have already created utility here. So here we have already encrypted this decrypt data function, Now we just need to simply use it. So const any variable name which you want to use here. I will use the same name equals to, and here you need to provide decrypt data where we would be passing encrypted username. And how we will get the encrypted username? So to get the encrypted username, we need to use this environment variable because we have kept our data inside this .env file, and to retrieve the data from this .env file, we need to use the environment variable. But how Playwright will get to know that from which file it need to read data? So that's what we would be mentioning into our configuration file, which is playwright.config.ts file. Here, while handling the multiple environment, we have used this .env.config method to configure our environment files. For now, I have commented out this particular portion which we have used inside this video. And here, let's provide this configuration again. And to provide this configuration, first, we need to install .env package if it is not already installed for you. That you can check inside your package.json file. For now, I do not have that .env package. I will show you how we can install it again. So let me open new terminal. And here we need to provide this npm i.env. The same command you can check onto this site, which is npmjs.com. So .env, npm, you can search here. Open this first link. See, npm i.env is the command. So the same command we have already written here. Hit enter, and as soon as you will hit enter, it will get installed, and the same you would be able to see inside the package.json under the dependencies. And now let's provide the configuration inside our playwright.config.ts file. So here let's first import .env from .env package. And now here let's provide the configuration where we would be mentioning that which environment file we want to use. So .env.config, and then within the parenthesis we need to pass the argument. So the argument would be the object where we need to mention key as path colon, and its value would be the path of .env file which we want to use for our project. So previously we have passed the path like this because we wanted to handle multiple environment files. But for now, just to keep the thing simple, I have created one environment file only, and that path we need to provide it here. So here, as we have kept our environment file, which is this .env file, inside the test data, so that path we will have to provide. So here, either we can provide path directly as the string where we can mention the relative path. So // and then this folder name, because currently we are inside this playwright.config.ts file. So now we are going to the parent folder by using this // and then we need to mention the folder which is test data. So test data / and then this file which we want to use. So .env. And apart from directly passing it as the string, we can use this resolve method. So let me comment out this portion, and let's use that resolve method. For that, we need to use this path, and to use this path, you will have to import the path also. Here we are getting this auto suggestion at the top. We need to import path from path. You can mouse over to see the details related to the path. This path module provides utility for working with file and directory paths. So here let's use this path. Of the path, we need to provide dot, and then resolve method we need to provide here. And for this resolve method, we need to pass the argument, and the argument would be our folder structure. So first we need to provide this test data as the string. So test data, and inside the test data, we have the file which is .env. So any one of the way you can use, either provide directly the relative path as the string or use this resolve method. It is totally up to you. And after providing this configuration where we have mentioned the path for our .env file by using this .env package. So now let's go to our test script file where we want to read data from this .env file. And now to read data from this .env file, as we have already done this configuration where Playwright knows that from which file we want to read our environment variables, we can simply use this process.env.environment variable name. So now let's save this encrypted data into one variable. So const uname or enc uname, any variable name you can give. Then colon, here let me define the type as any, because either we would be receiving the string or the undefined from this process.env.ts. So that's why I'm giving this any rather than providing a string here. And here we can provide process.env dot the environment variable name, which we have provided here inside this .env file as the key. So this encrypted uname we want to fetch. So after process.env dot provide this name. And now we have received our encrypted username, and that you can use inside this decrypt data to get the decrypted data from our utility method. And here, as I've given any, let me remove it so you would be able to see the error. See, here we wanted to pass the string, but argument of type string or undefined is not assignable to the parameter of type string. So that's why I was using any. You can provide this also, which we have used to provide the secret key, where we have used the ternary operator in case of undefined, what we want to provide, right? Although we would not be receiving the undefined, but because of any typo error, that may be the case that we will not get the correct value, right? Now let's read the value of the encrypted password, which we have provided here, and then decrypt it. So again, const first, let's get this encrypted password. So enc pwd, any variable name you can give. Here let's again provide type as any equals to, and then this process.env dot this environment variable name. And again const, here we are going to receive this decrypted password equals to, and then decrypt data method from this utility which we have created. So decrypt data, and here we need to provide the encrypted password which we want to decrypt. And that's it. We are able to receive the decrypted password inside this variable, and that same variable we are using to fill the value inside the password field. And now let me start the execution. Again, I will use the terminal because I need to pass the secret key. Why so? Because inside this decrypt data method, we would be needing that secret key which we have used to encrypt this data, right? So like this, you can encrypt multiple set of data one time for your project, and then you would be using it every time by decrypting it. Let me use the bash command again, because here it is really easy to provide these environment variables value. So our environment variable name is secret underscore key equals to, and then the same secret key you need to provide, which you have used to encrypt the data. So wish infinite is my key name. After space npx playwright test. And once we will start the execution, both of these tests will get executed. Here it will take the encrypted data directly inside the test script file where we have mentioned it, and into second test it will take the encrypted data from the .env file, and then it will decrypt it. And before starting the execution, let me provide this page.goto here. I forgot to provide it for the second test block. Let me copy it from this first test block, and here inside the second test block I can provide it. Now let me start the execution. So hit enter after providing this particular command. See, our execution got started. So our first test got executed, and now our second test got executed successfully. The execution happened only onto the Chromium browser, because here inside our config file we have just configured Chromium project only. And see, in both the cases we got the passed result, where in first case we were keeping our encrypted data directly inside our test script file, inside the test block, and into the second case we were keeping our encrypted data inside the .env file. So the simple step we need to follow, we need to create .env file where we need to keep our encrypted data with this key value pair. We need to install .env package. We need to make the configuration inside our playwright.config.ts file, where we need to mention the path which will get used to read the data from .env file. So here we are setting this file, and then into the script file you need to simply use this process.env and then the environment variable name which you have created here. And then as we already created utility, so our code is very clean, right? We were just simply using this decrypt data after importing it. So decrypt data function, and here we have passed the encrypted data which returned us the decrypted data which we have used inside our TypeScript file. And similarly, rather than using this .env file, you can use the JSON file or any external file. Let me give one more example about this JSON file. About saving and reading data from the JSON file also, I have already covered into one of my previous video. So here into this Playwright tutorials script, you would be able to see this read test data from JSON file, one video. If you have not watched this video, I will provide link of this video into the description, or you can click onto this I button at top right corner to access this video. For now, I will just quickly cover this particular concept. It would be refresher for you also. So let me create one more test block. Let's copy the second test block only. Let's change the name to Encrypt Decrypt 3. And here we would be receiving data from the JSON file. So let me remove this portion where we were reading data from the environment variable. And to receive data from the JSON file, let me create one JSON file where we would be saving this encrypted data. Let's create the file here inside this test data only. So right click, new file, and let's give the name as secure data. Any name you can give. .json is the file extension which you need to give. And inside the JSON file, you need to provide these curly braces. And inside these curly braces, we need to provide key and value pair. So let's use the same key name which we have given inside this .env file, but giving this name inside the JSON file, it's totally up to you. The only thing is that you would be using the same name while retrieving data. And here, don't forget to put double quotes for the key name inside the JSON file. So double quotes, key name, colon, and then the value within the double quotes only. So let's copy this encrypted username and let's provide it here. After that, put comma, hit enter, and here we can provide second set of data. Let me copy the same key name just to save the time, colon, and then within the double quotes, the encrypted password. Like this, you can provide multiple set of data inside the JSON file. And to read this data from the JSON file, let's go to our TypeScript file. And here, first, we will have to import this JSON file. So import the file name, which is secure data from, and here we need to provide path of our JSON file. So double dot / to go to the project folder, which is the parent folder of this test folder. Here, test data / secure data.json, where we have saved our encrypted data. And now we would be using this secure data to retrieve data. So let's go to our test block where we need to use this secure data which we have got by importing this JSON file. See, we are already able to get the suggestion from this JSON file. Here we want to get the encrypted uname. And then the same process would be there. We would be decrypting the data by using the utility. So decrypt data and then encrypted uname, this variable name we can provide here. And similarly, we can do the same thing for the password. So secure data dot encrypted pwd is the key name, right? This one. And we are saving this value here, and then here we are decrypting it. If you don't want to save it inside the variable, so directly also here you can provide it inside the decrypt method, because here we are sure that we would be receiving the string only, right? We need not to pass it as any. So let me remove this line as well as this line. Here directly, let's provide the secure data which we have got by importing this JSON file dot the key name, and that's it. We are able to read data from the JSON file, right? It was very quick and clean also. And now let's once again start the execution by providing the secret key which is required for the decryption, because the same secret key we have used while encrypting this data, right? Here we have used the same key while we were encrypting our data. And now let's hit enter, and we should be able to see 3 passed tests. Although we are saving encrypted data in different ways, but we are able to retrieve that encrypted data, and then we are decrypting that data, and then we are using it. And that's it for this particular video. And now I'm pretty sure you should be confident about encrypting and decrypting your secure data. And now let me give you the quick recap. So here we saw that credential encryption is essential in automation testing to ensure security and confidentiality of sensitive data. And for that, we need to use this CryptoJS library to handle encryption and decryption. We installed these 2 prerequisites by using the npm i crypto-js command, and then npm i --save -dev @types/crypto-js. This second prerequisite is for providing the type definition for the CryptoJS library. And after installing the prerequisite, we saw that we can encrypt our data. For that, we need to import the CryptoJS from this crypto-js, and then by using this cryptojs.aes.encrypt, we can encrypt our data, where we need to pass the data which we want to encrypt, and then the secret key or the salt or the passphrase to encrypt our data. And then we need to convert it as the string. We can console log this encrypted data, and then we can save it for our further use, either directly inside the variable or into the files like .env or the JSON file. And then to decrypt the data, we need to use this cryptojs.aes.decrypt, where we need to pass the encrypted data as the first argument, and then the second argument would be the same secret key or the salt or the passphrase which we have used while encrypting our data. And then onto this decrypt method, we need to provide this .toString, where we need to pass cryptojs.enc.utf8 to get the decrypted data into human readable string. And then we can use this decrypted data into our test script. We also saw that we can create one utility where we can provide encrypt and decrypt function, where we can write the same code to encrypt and decrypt data. And we also saw that we need to take the secret key through the environment variable, which we can pass while starting the execution. We can use any of the terminal. For each terminal, there would be the different syntax to set the environment variable value, like this. And now to start the execution, we need to simply set the environment variable as per your terminal, and then to start the execution, you need to simply give this npx playwright test command. If you want to provide any specific flag related to the reporting or the browsers, that you can provide with your execution command. It's totally up to you. We also saw that we can encrypt the data using the Encryption VSCode extension, and then we can use that encrypted data for our test script. And it's the better way to create utility rather than writing this code every time. We also saw that we can save our data inside this .env file like this, and to read the data from the .env file, we need to use this process.env and then the environment variable name. And for that, first we need to configure the path of the .env file. And for this, we first installed this .env package, imported it here, and then we provided this configuration for this .env file, where we mentioned the path. And then directly by using this process.env and then the environment variable name, we were able to retrieve the encrypted data. And then by using this decrypt data function, we decrypted data and then used in our script. And we also saw one example where we saved our encrypted data into JSON file, into key value pair like this, and then we have retrieved the data. For that, first we imported this JSON file like this, and then we have used this to retrieve data. So secure data dot the key name, and then we decrypted that encrypted data by using our utility, and then we used that decrypted data inside our test scripts. And like this, if you want to save data into CSV file, or if you want to save data into fixture file, that also you can do. About test data in CSV file and in fixture file, we have already covered. You can go through those videos from my playlist also, and the same you can try it for your practice as your assignment. In case of any issue, let me know into the comment section below. And that's it from my end. You can click onto this first card to go to the next video. You can click onto the second card to access the whole Playwright tutorials playlist and stay tuned for my upcoming videos. If you have any comments, questions or doubts, you can let me know into the comment section below. Please like, share and subscribe to my channel. Thank you very much. Have a great day.